Hi, it's Lisa, and welcome to DBA 130, Database Theory. Years ago, databases were designed only by those with a background in computer science. And then in the 1990s, Microsoft released Access, and it became part of the Office Professional Suite, along with Word and Excel and PowerPoint. Well, the issue here was that now programs like Access were available to the end user, and when they saw Access inside of this suite, they thought, well, how hard could it be? It must be just like PowerPoint. I just need to get in and click around and I can figure it out. Well, this is what happened. Hi, something's wrong with my macro. Can you take a look at my database and see what the issue is? Or I think it's Access. Access seems to be acting up. And the question was always, is it really an application problem or an implementation problem, or is it really a logical design problem? And the issue really was that end users were given programs like Access, but they had no idea that there was a logical design phase that they needed to complete before they ever implemented their database into programs like Access. So similarly, let's say you were using Excel, but you didn't know the order of operations. And in Excel, you entered 5 minus 3 times 2, and you were surprised that the answer returned was not 4. So in other words, in Excel, Excel is only as good really as the arithmetic, the basic arithmetic that you know. Now we take arithmetic for granted. We've had years of school, so we have arithmetic down solid. But when it comes to database design, end users were given access to programs like Microsoft Access with no formal training and even no knowledge of logical design theory, which are rules based on set algebra. So here's another example. We know that the design of a house is detailed in a blueprint before it's built with hammer and nails. And similarly, a database is designed in an entity relationship diagram before it is built with software. So these diagrams are created in the logical design phase of the overall database development process, and this is the phase we cover in this course. So when you think about a blueprint, it makes sense, right? Would you build a house by simply grabbing a hammer and some nails, or, professionally, would you detail it out to the last millimeter before you began? And of course we know, professionally, we're going to use the blueprint. So this is our end goal. This is an entity relationship diagram, or ER diagram, and this is our deliverable. So you may think, well, how hard could it be? It looks like I just need to grab Visio, right, and create a couple of boxes. But what's difficult about putting this together is not the drawing of the boxes, but the logic and the rules that we have to follow in order to correctly place the tables where they should go and in relation to what other tables. So we study the rules of relational database theory, which were developed by Dr. Codd at IBM and others in the 1970s. And these rules include things like normalization. You might be familiar with normalization, or at least you've maybe heard of that term. We also factor in that rules can change. In other words, we look at the business rules that are unique to an organization, like FERPA, privacy acts, right? And those rules will sometimes change how we use the set algebra or the database theory rules. So in summary, when you take the rules of relational database theory coupled with the business rules, both of those together will inform your individual logical model for your database. So in summary, relational database models are a combination of the relational database rules and the business rules that are specific to your project. That's it.